All right, let's talk about permutations. Permutations and combinations are related to each other. In both cases, it's when you have a group of objects and you're supposed to pull part of those objects out and arrange them in some way. Don't arrange all of them, just part of them. Okay, so I guess I got ahead of myself. Let's just talk about permutations. If you're asked to find the number of ways you can arrange a group of objects and the order matters, use this formula. It's n factorial, which means it's n times one number less than n times one number less than that times one number less than that. Continue until you get all the way down to 1. As an example, let's say you're supposed to find 4 factorial. That's 4 times 3 times 2 times 1. You're asked to find 7 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1. For permutation, the order matters. And let me explain what that means with an example. 5 speakers: Alice, Brad, Clara, Debbie, and Elaine. There's 5 of them. Will address the student body. Each speaker will only speak once. If they draw lots to determine their order, in which they're going to speak, how many different orders are possible? So everyone is speaking. According to the permutation rule, the order does matter for this. It's just going to be 5 factorial, which is 5 times 4 times 3 times 2 times 1. And that product, I believe, is 120. Let me just check on my calculator real quick. 5 times 4 times 3 times 2 times 1, that's 120. Just a brief explanation of why that is that way. How many choices do we have for the first speaker? We have 5. Once that was spoken, how many choices do we have for the next speaker? 4. How many choices do we have for the following speaker? 3. And then 2, and then 1. The product of that is 120. Another example. 5 speakers are going to speak again. Each speaker will speak only once, same as the last time. If the speakers draw lots to determine their order, same as last time, here's something different. If Brad will speak immediately after Alice, how many different orders for the speakers are possible? Well, if Brad and Alice are locked together, Brad's always after Alice. That really means that we only have 4 different ways to do this instead of 5. Because we're treating them as one person. So this is 4 factorial, which is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. So this is 24 possibilities. 15. 5 speakers, Alice, Brad, are speaking. Student body, same thing. Each speaks once, same thing. It's going to draw lots, same thing. And now it says if Brad will speak immediately before or after Alice, how many different orders are possible? So we're going to build on the previous problem. It's 4 factorial again, because you're treating them as one person, but since they can switch orders, for every combination you could have another one, because you can switch their orders, which means that we need to double this. So it's 4 factorial times 2. 4 factorial we said was 24. 24 times 2 is 48. So that's 48. So this is what I was trying to talk about earlier. I got ahead of myself. This is when you're asked to find the number of ways you can arrange a smaller group from a larger group. The previous problems, our group was 5 and we were arranging all 5 people. So in this situation, you might be given 5 people, but you're only supposed to arrange 3 of them at random. So here's the formula where n is the elements from the larger set and k is the elements from the smaller set. So this is not so bad as long as you can determine when you're supposed to use it. 5 candidates are running for an office. The candidates who come in first, second, and third will be elected president, vice president, and treasurer. How many outcomes for vice president, president, and treasurer? So our group size here is 5, but we're only going to choose 3 of those. So that means we're going to have 5 factorial over 5 minus 3 factorial. That's that formula right above, which is going to give us 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 times 1. 2's cancel, 1's cancel. So you have 5 times 4 times 3. That's 20 times 3, that's 60. So the answer is 60. There's 60 different outcomes for these 5 different people running for president, vice president, and treasurer. All right, combinations. A combination is like a permutation, but in this case, the order does not matter. Permutation, the order did matter. The order in which you were chosen was important. For a combination, the order does not matter. And it's this formula that you see here, where n is the large set and k is the small set that you're choosing. So an example, 17. How many different ways are there to choose 4 socks from a drawer containing 9 socks? So you can see here the order wouldn't matter in which you choose the socks. Sock 1 has no special value versus sock 2 that you choose. So the formula is n factorial over k factorial times n minus k factorial. So n in this case is 9. K in this case is 4. 9 minus 4 is 5. This is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. 5, 4, 3, 2, 1's cancel. We can divide 8 by 4 and 2. 4 times 2 is 8, that cancels. We can divide 3 into itself once, into 6 2 times. If you multiply 9 times 7 times 2, you're going to get 126. So 126 ways to choose 4 socks from a drawer containing 9 socks. We're going to look at some data here. I copied this picture just so we could easily see it with each of the questions. It's the same picture each time. So here we have Washington County, and it's the percent of people that have these different types of jobs. Total people in the county, 120,000. Then we got Warren County, different percentages, some are the same. Total people in that county is 160,000. Warren County, there's a question, number 18, has how many more people in the clerical category than Washington County? So clerical is here. To figure this out, we got to first figure out how many actual people are there in each of those counties that do that job. So in Washington, there is a total of 120,000 people, and of those, 6%, 0.06, are clergy. If you multiply those together, you're going to get 7,200. In Warren County, the population is 160,000. Of those, 10%, 0.10, are clergy. That's 16,000. It says how many more people? So we're going to subtract 7,200 from 16,000. That's going to be 8,800. Hopefully that's one of the choices. It is. Done. Same picture, different question. It's going to highlight the number of people. For Warren County, how many employment categories, so we're just looking at Warren for this, ignoring Washington. How many employment categories include more than 24,000 people? We got all these percentages, so what we should probably do for this is figure out what percent 24,000 is of the 160,000. If we divide those, we're going to get 0.15, which is 15%. So how many of these are bigger than 15%? 1, 2, 3. So the answer is C, 3. 20, same picture, different question. How many more people are employed in the service sector? So looking at service in Warren County than Washington. So once again, for this, we got these two different counties. We got to figure out how many people that is. So in Washington, I'm going to take 120,000 times 0.25. My handwriting, once again, is taking a turn for the worse. In Warren County, we're going to take 160,000 people, also multiply it by 0.25. We're going to get 30,000 and 40,000. What's the difference between those? It says how many more. The difference between those is 10,000, so that's answer D. One more. Same picture, different question. How many more people are employed as professional lawyers in Warren County than Washington? Well, it talks about professionals here. It doesn't talk about lawyers. There are more professions than lawyers, so this cannot be determined from the given information. So at this point, you should be able to finish exercise set 2.